We're going to be learning about equivalent expressions. What are equivalent expressions? Expressions that you see on the screen right now, 2x plus 6 and 2 into x plus 3. Are these two equal? Or this quadratic expression, is this equal to this quadratic expression? Or even tougher, is this equals to this? We're going to be learning this in this video. And it's very important that you will be able to identify the difference between expansion and factorization that leads to either of them. So for instance, 2x plus 6, if I were to take 2 common out of this, I'll be left with x plus 3, right? Because if I multiply 2 with x, I get 2x. And if I multiply 2 with 3, I get 6. 2x plus 6 is an expanded form of 2x plus 3. This is expanded and this is factorized. The process is called distributive property. So when you distribute that 2 with every expression, every term inside the bracket, you end up with the expanded term. Take a look over here. 12x squared and 18x plus 6 equals to 6 bracket 2x squared plus 9x plus 1. For instance, if I were to identify what can I take common from all three of these, which number would divide all of them? I can see 6 is a factor of the entire expression. What's left inside the bracket? 2x squared. How did I figure that out? Because if I multiply this with 6 with 2x squared, I'll end up with the same number. That goes to show it's correct. What do I multiply 6 with so that I end up with 18x? I'll be multiplying it with 3x. And what do I multiply 6 with so that I end up with 6? I'll be multiplying it with 1. So there's a little mistake over here. This should be 3x. 6 bracket 2x squared plus 3x plus 1. They're both equal expressions. Take a look over here. There's another one. In this we are going ahead with a property called midterm breaking. Imagine that if I were to ask you to factorize this expression, what will you do? The first thing that you're going to do is label the product. Product is the first term multiplied with the last one. 4 into 9 gives you 36. And the sum is basically essentially the middle term written down as it is. Now you need to break down the product into factors, which when multiplied give you 36. The factors of 36 are going to be 1 into 36, or it can be 2 into 18, or 3 into 12, going on 4 into 9. 5 doesn't divide 36. 6 into 6. If we just study these, are we able to come up with a combination of these two numbers which when added give you 12 and which when multiplied give you 36? Now all of these multiplied will give you 36, but which one of these when added give you 12? 1 and 36 not possible. 2 and 18 is not possible. If I do 18 minus 2 or any other method, it would not fit. 12 and 3, if I add them up, I'll never get 12. 4 and 9 close enough but not there. 6 and 6, if I add 6 and 6, I'll get 12, and if I multiply that, I will get 36 as well. So let's try to break it down. I can write it as 4x squared plus 6x plus 6x plus 9. Now what can I factorize out of the first two terms? I can factorize 2x. That's what I can take common. That's what I can take away from both of them. So if I take away 2x from the first term, I'm left with 2x inside. Or if I multiply 2x again with 2x, I'll end up with 4x squared. There are two ways of looking at it. Now what do I multiply 2x with so that I can get a 6x? 3. Similarly, now what can I factorize out of the last two terms? I can see they're both multiples of 9. So I'll take 3 common. What's left inside the bracket? X plus 3. Sorry, 2x plus 3. One sign that goes to show that my answer is correct so far is these two brackets should match. So I'm going to write them once, 2x plus 3. And whatever is left outside the brackets, I'm going to write that over here as it is. Now how do I know that I ended up with the correct answer? If I multiply them back, I should get the question that we started off with. Let's do that. So 2x into 2x gives us 4x squared. 2x multiplied by 3 gives us 6x. 3 multiplied by 2x gives us 6x. And 3 multiplied by 3 gives us 9. If I add them together, 4x plus 12x, 4x squared plus 12x plus 9. If you notice, I have ended up with the same answer that we had in the question. That goes to show these two expressions are equivalent.